Hello there, and welcome to Science for Sleep. I'm glad you found your way here tonight. Maybe you're stretched out in bed, the lights dimmed, or you've tucked yourself into a quiet corner where the world feels a little softer. Perhaps it's late, and the hum of the day has faded to something calm and distant. Wherever you are, this is a space made for you, a place to slow down, to let your thoughts wander without hurry, and to drift towards something bigger than today. Tonight, I want to take you into a story that is always unfolding, one you are part of even as you listen. It's the story of time itself, and the quiet engine that keeps it running. Entropy. What time is it where you are right now? Maybe midnight. Maybe an early morning you didn't plan on seeing. Time is passing either way, steady, unbothered, slipping from one moment to the next. You felt it your whole life without needing to think about it. But why does it move at all? Why do you wake up and grow older? Why do things fall apart instead of falling back together? Why is yesterday always behind you and tomorrow always out of reach? There's a reason. It's simple, and it's everywhere. Though it hides in places so ordinary you hardly notice it. And once you see it, you'll start spotting it in your coffee cup, in the air you breathe, in the quiet tick of your own heartbeat. Entropy is not loud. It doesn't crash in or announce itself, it just keeps time. If you're already feeling yourself unwind, I'd be glad if you tapped that little like button or subscribed. Only if it feels natural. I make these for you. For anyone who wants a calm corner of the night where science isn't a lecture, it's just company. And if you're listening from somewhere specific, maybe a small town, maybe a city that never quite sleeps, maybe the middle of nowhere, tell me in the comments. I love seeing where this map of quiet mind stretches. So, let's begin. Take a slow breath. Let your shoulders drop a little. There's no rush here. Imagine for a moment that the universe has a clock. Not the kind with ticking hands or glowing numbers, but a clock that you can't hear or see, and yet it moves everything forward. That clock is entropy. It doesn't count seconds. It doesn't keep appointments. It only does one thing. It makes sure the future is different from the past. If you've ever spilled a glass of water, you've seen it at work. The water doesn't leap back into the glass. A broken plate doesn't put itself back together. A melted ice cube doesn't refreeze itself on the table. You know this without needing an equation, because you've never seen it happen any other way. That is the arrow of time. It isn't set by the ticking of a watch or the rotation of the earth. It's set by the fact that things only move in one direction, from order to disorder, from neat to scattered, from concentrated to spread out. That's entropy. And it's not just a rule. It's the hidden current that pulls everything forward. You might be thinking, well, that sounds a little grim. If everything's always falling apart, what's the point? But it's not about destruction. Entropy isn't a villain. It's simply the way the universe keeps track of what has already happened. When you pour cream into coffee and stir, the swirling patterns fade and settle into something uniform. It's not worse. It's not better. It's just what happens. Entropy doesn't erase beauty. It gives it context. It's the reason you remember what came before, and why you know that tomorrow hasn't happened yet. Right now, as you're lying there, entropy is at work in ways you don't even notice. Heat from your body is spreading into the air. The device you're using to listen is giving off a tiny bit of warmth as it runs. Outside, winds are mixing the atmosphere, oceans are redistributing salt and temperature, and stars are burning themselves slowly toward their eventual quiet. It's not fast, it's not loud, it's not even something you can see. But if entropy ever stopped, so would time. Here's something to try. Picture a deck of cards perfectly sorted, aces on top, kings at the bottom, everything in its place. That's low entropy. Now imagine shuffling it once, then again, then again. With each shuffle, the order fades. You could keep shuffling forever, and it's almost impossible for the deck to ever return to its exact starting point. That's what time is doing. Not because someone's pushing it forward, but because the universe naturally moves toward the states that are easiest to reach. the ones with more ways to exist. A neat deck is rare, a messy deck is easy. That's not a flaw. That's how everything you know unfolds. Even your own memories depend on this. You remember the past because it was more ordered. The marks it left in your brain were carved in one direction. You don't remember the future because it hasn't happened yet, and because entropy hasn't written it down. It will, but not yet. And when it does, it will do it the same way it always has, one irreversible step at a time. Now think about something as simple as an ice cube. You take it from the freezer, set it on the table, and watch. It melts. The water spreads out. Molecules that were locked into a rigid structure now roam free. That's entropy in motion. Could it refreeze on its own? In theory, the laws of physics don't forbid it. But in practice, you'd have to wait longer than the age of the universe to see it happen. That's how tilted the balance is. Things move forward, not backward, because there are far more ways to be disordered than ordered. It's not a rule written down anywhere. It's just statistics on a cosmic scale. If that sounds distant or abstract, bring it closer. Your body is a constant little battle against entropy. Every second you burn energy to hold yourself together, to repair cells, to keep warm, to keep living. When you eat, you take in fuel that was once sunlight, captured by plants, concentrated into chemical bonds. You break it down, spread it out, and in the process, you stay alive. Life itself is a kind of borrowed order, a small pocket of structure swimming against the tide for a little while, and when you sleep, even that is part of it. You're restoring, repairing, organising, but the tide never really stops. It only pauses enough for you to keep going, and that's the strange quiet comfort in all of this. Entropy isn't an enemy to be beaten. It's the reason you can fall asleep at all. It's why days end and new ones begin. It's why the universe moves instead of standing still. It gives time a direction. Without it, nothing would ever change. You wouldn't grow, stars wouldn't shine, water wouldn't flow downhill. Everything would simply sit there, unmoving, forever. Instead, you're here, breathing, listening, feeling time move because the universe has a built-in preference for change. The heat from the sun spreads through space. The stars that light up the sky burn down slowly, scattering their energy into the dark. One day, far beyond your lifetime, everything will spread out so much that the universe will reach its quiet end. Heat death, where every bit of energy is evenly spread and nothing more can happen. That's the ultimate destination of entropy. But that's not tonight. Tonight is just one moment in the middle of the story. You, the room you're in, the air you're breathing. This is all temporary order, held together for just long enough to be lived in. And if you look closely, you can see entropy in the smallest things. A cup of tea slowly cooling on the table, a candle burning lower, its wax melting and mixing with air, even your breath, warm when it leaves you, spreading out into the room until it's no longer yours, but part of the air itself. These are not dramatic events. They don't demand attention, but they are the universe's quiet clock, ticking in a language older than timepieces. So as you settle deeper into the stillness around you, remember this. You're surrounded by a process so steady and certain that you almost never think about it. You don't need to. You only need to feel the passage of time, one moment after another, each carried forward by entropy's unseen push. And as you rest here, I want to follow that thread further, because entropy doesn't just move quietly in the background. It's the reason time feels like it flows at all. And if time flows, then there must be an arrow, a direction, a before and an after. Time has a way of feeling simple when you don't look too closely at it. One moment follows another, things change, and that's that. But if we're going to understand why this flow exists at all, we have to look at what sits underneath it. We have to ask what entropy actually is, not just in passing, not just as a word you've heard in science videos or textbooks, but in a way that makes sense for you, right here in this quiet moment. The first thing to know is that entropy isn't chaos. People sometimes use the word that way. Messy room, high entropy, broken machine, high entropy. But that's only the shadow of what it really means. Entropy is not about mess. It's about counting. It's about how many ways a thing can exist. The more ways there are for something to be arranged without changing what it looks like from far away, the higher its entropy. Think of a jigsaw puzzle. When it's all in one piece, there's only one correct way for those pieces to fit. That's low entropy. Now imagine dumping the pieces back into the box and shaking it. Suddenly there are thousands, maybe millions of ways for those pieces to be scattered. That's high entropy. And the funny thing is, the second state is not wrong. It's just overwhelmingly more likely. That's why time pushes in one direction, from the rare, precise state toward the one with endless possibilities. You can see this even more clearly if you think about air. Right now, the air in your room feels even. You're not sitting in a pocket with all the oxygen on one side and all the nitrogen on the other. That's because there are trillions of ways for air molecules to spread themselves out evenly, and maybe one in a number bigger than you can imagine where they all clump to one side. Physics doesn't forbid the clumping. It's just so absurdly unlikely that it may as well never happen. This is the heart of entropy. It's not a force pushing things apart. It's probability. It's statistics, but written so deeply into the fabric of nature that it feels like a law. And the moment you see it this way, it stops feeling like an abstract concept and starts to look like the quiet background rule for why everything familiar works the way it does. Take heat, for example. When you hold a warm mug of tea, that warmth spreads into the room. You never see it run in reverse. You never feel the air in your room suddenly donating all its heat back into the mug to make it steaming hot again. That isn't because heat doesn't like you, or because there's a hidden rule against it. It's because there are countless ways for warmth to spread out, and practically none for it to neatly flow back in. The spreading is simply what's most likely. Even your own body is living proof of this. Every cell you have is constantly fighting entropy, not because entropy is out to get you, but because maintaining order requires effort. You burn energy to hold your molecules in place, to repair what gets worn down, to keep the probability from running away with you. And that's what life really is. A kind of ongoing negotiation with the natural drift of the universe. When scientists first began to understand this, they realized that entropy is more than just a property of heat or energy. It's a way of keeping track of information, of what's happened and what can happen next. You can imagine it like a record book that the universe writes in automatically. Each event, each shift from order to disorder is a line in that book. That's why you can't unspill a glass of water. You'd not only have to move every drop back into place, you'd also have to erase the record of what already happened, and the universe doesn't do erasures. If you've ever wondered why we remember the past but not the future, entropy is the reason. The past is written. The record exists. The future hasn't been recorded yet. It's waiting for the next line. And while you may not see that record in any obvious way, you feel it every second of your life, because that record is what gives time its sense of direction. Now, here's something worth sitting with for a moment. Imagine, just for fun, that you filmed yourself knocking over a cup of marbles. If you played that film forward, the marbles would spill and bounce, scattering across the floor. Perfectly normal. If you played it backward, though, you'd laugh, because suddenly those marbles would all roll back in perfect unison and leap back into the cup. You know instinctively that's not how the world works. That instinct, that's entropy speaking. Your mind has learned to trust the arrow of time because you've watched it play out your entire life. But here's where it gets even stranger. At the level of individual particles, the tiniest pieces of reality, there's nothing in the equations that says time has to move forward. A single collision between two particles can look the same whether you run it forward or backward. Time's direction only really appears when you zoom out, when you take trillions of those particles together and let probability take over. That's where entropy comes in. It doesn't care about one particle. It cares about all of them, all at once, and in that vast crowd of possibilities, forward wins every time. This is why entropy is sometimes called the hidden engine of time. It's not pushing the universe like a hand on a clock. It's simply tilting the table ever so slightly so that everything rolls one way instead of the other. You can almost hear it if you pay attention, not as a sound, but as the quiet logic behind every warm cup cooling down, every candle burning out, every memory that feels like it's behind you instead of ahead. And this isn't just happening far away or in a lab, it's happening right where you are. Your room, your breath, your body, they're all little theatres where entropy plays out. The warmth of the device in your hands is radiating outward, one tiny photon at a time. The heat in your blanket is spreading until it matches the air around it. None of this is dramatic, but if you could see the microscopic dance behind it, you'd realise it's as constant and certain as gravity. This is why understanding entropy isn't just about physics. It's about noticing that the simplest things you take for granted, why ice melts, why smells drift through the air, why your tea won't stay hot forever, are all connected to the same quiet rule. You don't need to force yourself to feel it. It's already there, holding time steady in the background while you listen. And now that you know what entropy really is, we can follow it further. Because it's one thing to say it explains why time moves forward. It's another to see how it shapes every single moment you've ever lived. And if there's an arrow to time, then we should look at where it points and what it leaves behind. If you've ever sat and watched the sun sink toward the horizon, you already know what it means to follow the arrow of time. The sky changes, shadows stretch, 1 minute becomes the next, and even if you don't think about it, you feel that steady pull forward. Nothing in your life ever runs in reverse. You wake up older than you were yesterday. You pour water into a glass and never see it leap back into the bottle. Even the quietest moments keep drifting away behind you, and there's no path that leads back. That simple truth, obvious, almost too obvious to notice, is the arrow of time. It's tempting to think of this arrow as just a habit of the mind, a way your brain strings events together, but it's not just you. The arrow of time is stitched into the way the universe itself works. It's what separates the past from the future, and the reason it exists at all comes back to entropy, the quiet engine you can't see, but that is always there. Imagine a tidy room, everything in its place. Now imagine you walk in, toss a few clothes on the floor, scatter some books across the table, leave a mug on the desk. You didn't have to try very hard. A small amount of effort was enough to turn that tidy state into a messy one. Now, try to imagine the reverse. All those clothes folding themselves, the book stacking neatly, the mug sliding back into the cupboard. It doesn't happen. Not because the universe dislikes clean rooms, but because the arrow of time points the other way. There are more ways for things to be messy than to be ordered, so that's the direction time takes. You've probably heard people say you can't unscramble an egg. It's the same idea. When you crack an egg and whisk it, you're not breaking a law. You're just letting probability do its thing. There are trillions of ways for those yolk and whites to mix, and only one way for them to unmix. The arrow of time simply follows the path that almost everything can travel, instead of the one narrow route that almost nothing does. And yet, this isn't just about broken eggs or messy rooms. It's about why your memories face backward instead of forward. You can recall the sound of your favourite song from yesterday, but you can't hear tomorrow's melody ahead of time. You can picture where you were an hour ago, but not where you'll be an hour from now. That's because the past has already left its trail. It's written into the arrangement of things, your brain, your surroundings, even the cooling cup of tea on your desk. The future hasn't happened yet because entropy hasn't spread that far. There are no footprints ahead of you. This arrow doesn't just run through your life, it runs through the universe itself. Look at the stars. They burn because hydrogen fuses into helium, because energy flows from concentrated pockets into wider, more even spreads. That process only runs one way. A burned-out star doesn't rewind itself back into a bright new sun. The arrow of time pushes forward and the stars go with it, just like everything else. If this sounds heavy, it doesn't need to be. There's a kind of quiet comfort in the fact that this arrow is so dependable. You can set your watch by it. You can build your whole life on it. No one has ever woken up to find time moving in reverse. Even when things feel uncertain, this one rule stays steady. The universe keeps marching from order to disorder, from past to future, one step at a time. But here's something that makes it even more interesting. If you could somehow rewind the universe, every particle, every atom, every grain of dust, back to where it was billions of years ago, you wouldn't just be reversing time, you'd be reversing entropy. You'd be marching uphill against the single strongest trend in existence. That's why we never see it happen. It's not that physics forbids it, it's that it's so unimaginably unlikely that it's as good as impossible. This is why the arrow of time feels so natural. You've lived your whole life inside of it. It's why you know, without anyone explaining it, that spilled milk doesn't pour itself back into the carton, that a burnt-out match won't burst back into flame. Every one of those little events is just entropy running forward, writing another line in the universe's record book, one you can read simply by remembering what came before. And if you zoom out far enough, you start to see that this arrow doesn't just explain why things happen, it also gives the universe a kind of story. Stars are born, burn and die. Planets cool. Oceans form and evaporate. Even galaxies collide and settle into new shapes. Every step of it is one more turn of the arrow, one more irreversible change written into the fabric of time. And yet, while this arrow is universal, it also touches you in the smallest, most personal ways. Your own heartbeat is a little marker of it. Each one happens and then is gone forever, folded into the past, replaced by the next. Your body itself is aging in the same direction as the stars, not backward, not paused, but forward, always forward. And it's all because entropy won't allow time to stand still. Once you see this, you can start to notice it everywhere. In the way a warm drink cools, in the way sounds fade into silence, in the way a day begins and ends and never loops back. You live in the middle of this one-way current, and the quiet part is, you always have. But if time has an arrow, and entropy is what points it, that raises an even bigger question. What does this mean for the future? If everything is always spreading out, cooling down, and settling into simpler states, where is all of this heading? And if there's a destination, how far away is it? When you start thinking about how time moves forward, it's easy to picture it as a straight path, a line stretching from order to disorder, from neat beginnings to scattered endings. But that's not quite what it feels like when you slow down and really look at it. The shift isn't sharp or violent, it doesn't crash or tear. Most of the time it happens quietly, almost gently, like fabric loosening its threads. This is what makes entropy so strange. It isn't about things breaking, it's about things softening. Imagine an ice cube melting in a glass. At first it's sharp-edged, solid, defined. You can pick it up, hold it, hear it clink against the glass. Then slowly it blurs, the edges round off, the structure unravels, the cold, stiff order of the ice slips away, and in its place water spreads out freely, smooth and formless. That's entropy at work. Nothing explodes, nothing shatters, it just lets go. You can see it everywhere if you pay attention. A hot cup of tea steaming in a quiet room. At first there's a clear difference between the tea and the air around it. One is warm, the other cool, but the longer you wait, the less that difference matters. The heat drifts out, dissolving into the room until the tea is the same temperature as the air. The sharp contrast fades, replaced by an evenness so complete that nothing about it stands out anymore. Entropy always moves this way, from the clear and separate toward the blended and balanced, from order to softness. And it isn't just in small things. The same slow shift plays out across the entire universe. Long ago, the cosmos was full of sharp contrasts. Hot, dense, crowded with energy packed into every corner. Over time, that energy spread. Stars ignited, burned, and cast their heat outward. Planets formed and cooled. Galaxies spun into their graceful shapes. Step by step, the universe smoothed out, trading sharpness for balance, trading intensity for quiet. This is the same process you see in that melting ice cube stretched across billions of years. What makes this so fascinating is how natural it feels. You don't notice it happening in real time because entropy doesn't rush. It doesn't need to. It just waits. And while it waits, it turns the rigid into the relaxed, the structured into the simple. A drop of ink in water doesn't vanish. It spreads until it belongs everywhere at once. A once bright flame burns down, its energy drifting out into the room as nothing more than warmth you barely feel. That's the universe's most patient habit, smoothing out the sharp edges of everything it touches, and you live in the middle of it. The warmth of your body isn't staying locked inside you. It's drifting outward in tiny exchanges you never notice, equalizing with the room. Every breath you exhale mixes into the air, one small thread woven into something bigger. Every object around you, from the pillow under your head to the screen in your hand, is quietly bleeding heat into the space around it, step by step, until it all evens out. This isn't destruction. It's not even loss. It's just what happens when order has more ways to loosen than to tighten. A deck of cards can only be perfectly stacked in one way, but it can be shuffled into millions of arrangements. It's not that those arrangements are wrong, they're simply easier. The universe always drifts toward the easier state, because easier is what's overwhelmingly likely. There's something oddly peaceful in that. Entropy isn't a hammer striking things down. It's more like a tide wearing away at sharp rocks until they turn smooth. It doesn't erase everything instantly. It just makes the complicated simpler, the concentrated more even, the rare less rare. Think of the stars again. When they burn, they aren't fighting entropy. They're part of it. They pour their heat into the dark, not because they choose to, but because there's only one way for their energy to spread, and 1,000 ways it can't go back. Even their light, once it leaves, is gone forever from them, scattered out into space until it fades to almost nothing. And yet, without that slow unravelling, there would be no warmth, no light, no time. And this softening doesn't just happen far away in space. It shapes everything around you, even the quiet things in your own room. The hum of an appliance, the fading warmth of a recently brewed cup of tea, the air slowly blending into a single even temperature. It all runs on the same rule. Over and over, the universe trades the rare for the common, the concentrated for the spread out, until what's left is balance. But balance isn't the end. Entropy doesn't stop when something softens. It just keeps going, step by step, carrying everything forward. And if that's true, then there's something else we have to talk about. Because once you see how this works on a small scale, you can follow it all the way out to the biggest question there is. If the universe keeps softening forever, what happens when there's nothing left to even out? That's where the story of entropy gets even stranger, because the same quiet process that cools your tea and melts your ice cube is also steering the entire cosmos toward a distant future, one that feels almost impossible to imagine. And to get there, we need to start small. We need to go back to something familiar, something you've probably seen 1,000 times and never thought about. A simple cup of tea, cooling down, and what it really means for everything else. Picture this for a moment. You're sitting in a quiet room with a fresh cup of tea. Steam curls up in thin threads, and for a little while it's warm enough that you can feel the heat through the mug. It's simple, ordinary, something you might not even think twice about. But in that single cup of tea, you're watching the whole story of the universe play out in miniature. At first, the tea is hot, and the air around it is cool. That difference, hot here, cold there, is a kind of order. It's a temporary imbalance, a momentary pocket of contrast. But you already know what happens next. The tea cools, the steam fades, the air warms just slightly. Bit by bit, the sharp difference between the tea and the room disappears until everything reaches the same quiet temperature. That's entropy. It's not just about the tea, it's about the way the universe works. Energy doesn't stay locked in one place. It spreads, it equalizes, it slips from places where it's concentrated into places where it's thin, because there are far more ways for that to happen than for it to reverse. And every time it does, the arrow of time moves forward. If you think about it, that little mug is a map of the cosmos. Right now, stars are doing exactly the same thing. They burn through their fuel, pouring heat and light into space. Planets cool, just like the tea on the table. Galaxies slowly scatter their energy outward. It's the same story, just stretched over distances so large you could fit 1,000 Earths inside a single frame and still not see the edges. You don't notice it on that scale because it takes so long, but every second it's happening. The universe is cooling down step by step the same way your tea is. Not in a hurry, not in a rush, just steady, inevitable, quiet. And this isn't just some far-off phenomenon for scientists to study. You can feel it in your hands every time you wrap them around a warm mug. You can see it in the fading steam. You can trace it in the way things settle, hot to warm, warm to cool, difference to balance. This isn't a coincidence. This is the very process that defines the flow of time. Now here's the part that's both unsettling and strangely calming. If you follow this process far enough, if you imagine every star cooling, every burst of energy evening out, every difference in temperature and motion finally smoothed away, you end up with the ultimate quiet, the heat death of the universe. A time so far in the future it almost feels meaningless to think about it. No stars, no warmth, no pockets of energy left to spread. Just everything stretched into perfect still balance. That sounds like an ending, but it's not the kind of ending you can picture like the closing of a book. It's slow. It's so slow that whole civilizations could rise and vanish 1,000,000 times over before it's even noticeable. It's not destruction. It's the same thing that's happening to your tea, only stretched over the longest possible timescale. But right now, sitting here in this small, quiet moment, that distant future doesn't matter. What matters is that you're living in the middle of the process. Your tea is still warm, the stars are still burning, there's still movement, still difference, still time. Entropy isn't finished yet. You're part of a universe that's still busy shifting, still spilling energy outward, still unfolding its story one cooling cup at a time. If you really think about it, there's something comforting in that. Even though you know the tea will cool, you enjoy it while it's warm. Even though you know the day will fade, you watch the sunset anyway. The fate of everything isn't a reason to despair. It's what makes this moment matter. This temporary order, the stars, the warmth in your room, the cup in your hand, is exactly what gives time its shape. And if you want to see entropy even more clearly, you don't need to look to distant galaxies or the far future. You only need to pay attention to the next small thing you touch. Watch how heat moves. Watch how balance creeps in. In that simple, ordinary change, you're watching the deepest truth of the universe at work, and this truth doesn't just explain the cooling of tea or the burning out of stars. It explains why nothing can ever really run backward. You'll never see that tea grow hot again on its own. You'll never see broken things reassemble themselves without help. You'll never see time turn around, because entropy doesn't stop, it doesn't reverse, it only carries everything forward, one quiet step at a time. And that forward pull doesn't just shape objects, it shapes you. Your body, your breath, even the energy in your muscles all obey this same rule. Every second you're alive, you're trading ordered fuel, food, warmth, oxygen, for motion and heat that dissipate into the world around you. You don't notice it, but you're part of the same flow that cools the tea, dims the stars, and moves the universe from contrast toward calm. If you let yourself sit with that thought for a while, it changes how you see things. Time isn't just a line you travel along. It's the result of something deep and constant happening beneath everything you know. You're not just in time, you're inside entropy's slow, endless drift. And once you notice it, you start to wonder about what else it touches. Because if entropy drives the cooling of your tea and the fading of the stars, then it must also hold the key to why energy itself behaves the way it does. It must explain why nothing from the smallest atom to the largest galaxy can ever escape this quiet, inevitable spreading out. Everywhere you look, energy is moving. It flows from warm to cool, from concentrated to spread out from one form to another. You don't have to see it to know it's there. You can feel it in the warmth of sunlight on your skin, in the glow of a lamp, in the quiet hum of a machine running in the background. And behind every one of those exchanges, entropy is at work, keeping a kind of record. Think of this record like a library, an invisible one, with no paper, no shelves, no walls. Every time energy moves, every time it changes or spreads out, it leaves a trace. That trace isn't written in words, it's written in the arrangement of the universe itself. Once energy has flowed, it doesn't flow back the same way. The record is permanent. It's what gives time its forward direction, one irreversible page at a time. You can see it in something as simple as lighting a candle. Before you strike the match, all the energy in that candle is locked away in the wax. It's stored, concentrated. The moment you light it, that energy spills out. Heat spreads into the room. Light travels outward. The air moves with the tiny flicker of the flame. You can't take that same warmth and pull it back together into the candle again. The energy is still there in the world, but it's scattered into forms that don't go back. One more line in the library has been written. That's the strange thing about energy. It never disappears, but it never returns in quite the same way either. The heat from a burning star doesn't vanish. It streams into space, carried away as light that keeps going forever, weaker and fainter as it spreads. That energy doesn't come back to the star. It's part of the universe now, archived in the same library that's been growing since the very beginning. And this library doesn't forget. When you boil water, the energy you used isn't erased. It lingers as heat in the air, as a slight rise in temperature in the walls and floor, even as the molecules in the water move faster and faster. Every bit of it is accounted for. Entropy doesn't lose track. It just keeps adding to the record, one transfer at a time, until the energy that was once focused and useful has been spread so thin that all that's left is balance. This is why you can run an engine or cook a meal or charge a battery, but you can't do any of those things with cold air alone. Energy isn't gone. It's simply been shuffled into forms that can't easily be used again. The sharp contrasts, hot here, cold there, have blurred. And once they blur, entropy locks the change in place. Even now, as you listen, this record is being written all around you. The device you're holding is giving off heat that drifts outward into the room. That warmth will keep spreading into the walls, into the air, into the endless background of everything else, until it's so evenly shared that it's impossible to notice. The universe is very patient. It doesn't erase what happens. It just files it away in this vast library of energy, where every change is permanent. What's remarkable is that this record is also the reason anything happens at all. If energy didn't flow from high to low, if entropy didn't keep count, the universe would be frozen. No warm tea cooling, no stars burning, no breath leaving your lungs and mixing into the air. That gentle one-way movement of energy is what makes time move. It's what turns possibility into memory. You can follow this library back to the beginning. At the start, when the universe was young, it was packed with energy crammed tightly into one hot, dense state. Back then, there were sharp contrasts everywhere. Pockets of heat, vast differences in density, enormous potential for change. Every bit of that potential has been slowly unwinding ever since, every step filed away in this invisible archive. Galaxies forming, stars igniting, planets cooling, oceans freezing and thawing. Each event another page in the book. And here's the part that ties it back to you. Your life, in its own small way, is part of that same record. Every meal you eat, every breath you take, every step you walk, it's all powered by borrowed energy being moved from one place to another. The food you eat carries sunlight captured by plants, sunlight that came from nuclear reactions in a star. You burn it, you move, and the energy spreads further. You can trace every heartbeat, every thought back to the same rule. Once you see this, even the simplest things start to feel connected. The heat leaving a candle, the warmth bleeding from a cup of tea, the stars slowly dimming in the sky. They're all the same story, written in the same universal library. It's quiet, but it never stops. It has been building since the first second of time, and it will keep building until there's nothing left to write. But before that distant quiet comes, there's something else to understand. Because entropy doesn't just explain how energy spreads, it also explains why some things can never be undone, why you can't unburn a log, or unshatter glass, or gather spilled heat back into a single perfect spark. It's not just inconvenience, it's the deepest rule there is. And once you see that, it changes how you look at everything. Because now it's not just about what energy does, it's about why it only ever moves forward. If you've ever cracked an egg into a bowl, you already know what's coming. The shell breaks, the yolk spills out, and with a quick stir, everything mixes together. It's so ordinary that you don't think twice about it. But here's the question. Why doesn't it ever go the other way? Why don't you ever see the yolk and the whites separate themselves, climb neatly back into their shell, and seal themselves shut again? The simple answer is entropy. Once that egg is broken, it moves from a state of very low entropy, a rare, orderly state, into one of almost limitless disorder. And the farther it goes, the more impossible it becomes to go back. Not because the laws of physics forbid it, but because the odds are so impossibly small that they may as well be zero. To unscramble an egg, every single molecule would have to reverse its motion. Every drop of yolk and every thread of egg white would have to find their original place again, down to the tiniest detail. In theory, the rules of physics don't say it's impossible, but if you waited for it to happen naturally, you'd be waiting longer than the age of the universe. That's how deep this one-way flow runs, and this isn't just true for eggs, it's true for everything. A shattered glass doesn't leap back together because there are countless ways for its pieces to stay scattered, and only one impossibly specific way for them to reassemble. A burned log never unburns because the energy released in the fire has already spread into the air, scattered so thin that it will never come back. Every event like this is a step forward in time, a change recorded in that invisible library entropy keeps. You've felt this your whole life, even if you've never called it by name. You know instinctively what can happen and what can't. You don't expect a puddle of spilled water to leap off the floor and back into its glass. You don't expect a warm cup of coffee to reheat itself. Your brain has spent every second of your life watching entropy do its work, and it has learned the one rule that never breaks. Things don't reverse. But there's something fascinating about why this feels so final, because at the microscopic level, the tiniest building blocks of reality don't actually care about forward or backward. If you could watch two molecules collide, you could run that little collision forward or in reverse, and the math would look the same. The difference only appears when you zoom out, when you look at all the molecules at once, all of them swirling and bouncing in their billions and trillions. Out of that vast sea of possibilities, almost every path runs in one direction. That's where time's arrow comes from. And this is why entropy gives time its sense of inevitability. You can't just pick out one egg or one glass or one tiny event and force it to undo itself. Everything around it, the air, the heat, the motion of every other particle, has already shifted to record what happened. To rewind a single thing, you'd have to rewind everything else too. The universe doesn't do rewinds. That might sound a little unforgiving, but in a way, it's what makes life feel solid. You don't live in a world that resets itself. You live in a world that moves forward, steadily, predictably, one change after another. entropy keeps time anchored. It gives you yesterday and today and tomorrow. It gives you memories that face backward and futures that stay unwritten until you reach them. And if you want proof, all you have to do is crack another egg. Watch how easily it falls apart. Watch how natural it feels for order to dissolve into something simpler. Then ask yourself why it never surprises you. That quiet lack of surprise is your mind recognizing entropy at work. But there's another side to this story. Because while entropy explains why you can't unscramble an egg or unburn a log, it also explains something else. Why every bit of heat in the universe flows the way it does, why every star burns the way it does, and why even the smallest transfer of warmth always follows the same quiet rule. And to see that, we have to look closer at the constant companion of entropy: heat. Heat is one of the simplest things we experience, but it's also one of the most revealing. It's the quiet language entropy speaks in every corner of the universe. When you feel warmth on your skin, when a cup of tea cools on the table, when sunlight spills across a room and fades into the air, you're not just noticing temperature, you're watching the most fundamental rule of time in action. Heat always flows from hot to cold. It never reverses on its own. A warm mug cools down. It doesn't get hotter unless you add energy from somewhere else. The air in your room doesn't suddenly give up its heat to make that mug steaming hot again. This isn't just a rule of convenience. It's the physical signature of entropy. Once heat spreads out, it doesn't come back. And the reason for that is simple. There are far more ways for heat to disperse than for it to concentrate. Think of a single spark from a fire. At first, it's focused and bright, carrying energy in one small place. But the instant it's released, it radiates outward in every direction. That energy races away as light and heat, scattering so thinly that you could never gather it all up again. Each bit of it drifts into the universe's vast library of energy, filed away permanently. This is why heat feels so tied to time. Every warm thing you touch is temporary. You can hold a mug of coffee in your hands, but even as you enjoy it, the heat is slipping away. It's not a failure of the coffee. It's just the universe doing what it always does, trading difference for balance, trading the sharp contrast of hot and cold for the even calm of everything in between. But this isn't just a kitchen table effect. It's cosmic. Stars burn because they are hot, because their energy is crammed so tightly into one place that it has no choice but to flow outward. Every ray of light they send into space is heat leaving a concentrated pocket and joining the larger sea of the universe. Once it leaves, it never comes back. That's why stars don't last forever. Entropy is quietly, steadily, spreading their energy away, one photon at a time. If you think about it, your own body is part of this same exchange. Every second, you radiate heat into the space around you. You can't feel it happening, but it's constant. Even as you sit in a room where the air feels still, tiny exchanges of warmth are taking place between you, the air, the walls, and everything else nearby. Nothing is perfectly isolated. Entropy doesn't allow it. This is also why engines run, why fires burn, why anything in the world moves the way it does. When you use heat to boil water, or run a car or power a turbine, you're not creating energy. You're moving it from a high, concentrated form into a lower, spread out one. And once it spreads, it doesn't gather itself again. You can never get 100% of that energy back, because each step leaves a trace of heat dissipating into the surroundings. This is the quiet companion of entropy. It's not loud or sudden. It's patient. It fills every corner of the universe, equalizing every difference until there's nothing left to equalize. Heat is how entropy writes time into the world, one transfer after another, never stopping, never reversing. Even right now, the room you're in is part of this endless process. Every object in it is exchanging tiny amounts of heat with everything else. It's too subtle for you to notice, but if you could see it, you'd find a constant dance of energy. No winners, no losers, just an ongoing shift toward balance. That balance is why your tea cools, why your breath fogs in the cold, why the universe itself will one day be a thin, even spread of energy where nothing more can happen. But that day is unimaginably far away. For now, there's still warmth. There are still stars and fires and living things that borrow little pockets of energy to stay alive. Heat may be entropy's companion, but it's also the reason there's motion, change, and time itself. And if heat shows us how energy moves, then it also points us towards something even larger, the way entropy has shaped the universe from its very beginning, and how it will keep shaping it until the very end. If you want to see entropy at its grandest scale, you don't have to look at a cooling cup of tea or the quiet warmth of a room. You only have to look up at the night sky. Every star you see, and even the ones too faint for your eyes to catch, are living proof of the same rule that guides everything else. Energy flows, heat spreads, and time only moves forward. A star is a furnace, but it isn't burning in the way a candle does. Deep inside, immense pressure squeezes atoms together until they fuse, releasing staggering amounts of energy. That energy doesn't stay locked inside. It pushes outward as light and heat, racing into space in all directions. Every second, a star empties itself into the universe, its concentrated fuel scattering further and further away, and entropy records each step. That's why stars shine at all. If the energy inside them didn't have anywhere to go, if there were no difference between their blazing heat and the cold vacuum around them, they would simply sit there, dark and unmoving. It's the contrast, hot against cold, energy against emptiness, that drives the whole process. Entropy is what makes that contrast fade, but in fading it gives the universe its motion. You can think of it like a cosmic bonfire. Each star burns down slowly, throwing its heat into the darkness. Some of that energy warms planets, some of it escapes into empty space, but none of it ever returns to the star. Over millions and billions of years, each star's fuel runs lower, its light softens, and eventually it fades. In its place, the universe grows just a little more even, a little closer to balance. And yet, this long, slow unwinding is also the reason anything exists in the first place. Without it, planets wouldn't form, oceans wouldn't move, and life wouldn't begin. Every breath you take traces back to a star burning its fuel long ago. Even the warmth in your body right now is borrowed starlight, captured by plants, carried through food, and spent in countless tiny processes inside you. Entropy has been at work since the very first second of time, and stars are its most visible messengers. But stars don't last forever. Eventually their fires dim. Some collapse into dense remnants like white dwarfs or neutron stars. Others explode, scattering their material across space. In both cases, the result is the same. Their concentrated energy, once locked in a single place, spreads out. Even their deaths are just one more step in the slow, one-way flow toward equilibrium. This is what ties the smallest and largest scales together. The same process that cools your tea and warms a room is the one that drives the life cycles of suns. It doesn't change its nature just because it's happening across galaxies instead of kitchens. Entropy is universal. Whether it's a flickering candle or a dying star, the direction is always the same. If you watch the sky long enough, not in human years but in cosmic time, you'd see this clearly. Stars would ignite, burn and fade while new ones are born from the ashes of the old. But over unimaginable spans of time, fewer and fewer would appear, until one day, far in the future, the stars would simply stop coming. What would be left is a quieter universe, still moving, still spreading its energy thinner, but without the brilliant fires that once lit it. And yet, we are nowhere near that stillness. Right now, the sky is alive with burning suns, each one spilling energy outward, each one pulling time forward with it. You're living in a universe that is still bright, still full of motion, still in the middle of its long story. The fires haven't gone out. The great unwinding hasn't reached its end. For now, the clock is still ticking. And if stars are the grandest example of this flow, they also point us toward the question that lies at the heart of entropy. Where is all of this headed? Because if the energy in every star eventually spreads out, and every difference eventually fades, there must come a time when nothing is left to change. But before we reach that distant horizon, there's something else we need to look at. What happens when the fires dim completely, and the universe finally begins to settle into its quietest state? If you follow the trail of entropy far enough, it leads to a future that feels almost impossible to imagine. A time so distant that the stars we see now will all be gone. A time when no new suns will flare into existence. A time when the fires that once lit the universe have burned out, one by one, until all that's left is quiet. This is what physicists call the heat death of the universe. But don't think of it as an ending that happens suddenly. It isn't a collapse or a crash. It's a slow fading, a soft and steady settling into stillness. Right now, the universe is still full of contrast. Stars burn hot while the space between them is cold. Galaxies spin. Planets orbit. Energy moves from place to place. But entropy is always working, smoothing those differences out. Over billions upon billions of years, heat spreads. The sharp edges between hot and cold blur. The energy that once powered stars and drove motion through the cosmos drifts away, thinner and thinner until there's nothing left to even out. By the time that happens, every star will have lived its life. Some will collapse into dense, lightless remnants. Others will scatter their material across space, seeding it for new stars that will in turn burn and fade. But even that cycle can't last forever. There is only so much fuel to burn, only so many chances for energy to be gathered together before entropy scatters it for good. When that scattering reaches its final stage, there will be no more stars, no more heat to flow from one place to another, no more bright sources of difference for entropy to erase. The universe won't end with a bang or a flash. It will simply coast into a state of perfect balance, a smooth, even spread of energy where nothing new can happen. Time, in any meaningful sense, will have run out of reasons to move forward. And yet, strangely enough, this isn't a sad picture. It's not the kind of ending that takes anything away from the present. It's so far off that it almost lives outside the concept of future as we know it. Entire civilizations could rise and fall countless times before this quiet horizon is even close. You, right now, are in a universe still rich with warmth and movement, surrounded by burning stars and flowing energy. Heat death is not a threat. It's simply the distant conclusion of the same process you see every day in the smallest things. When you watch a hot drink cool on the table, you're watching a tiny piece of this grand story. When you see firewood burn down to embers, you're seeing a miniature version of the same principle that will one day dim the galaxies. The difference is only scale. The rule is always the same. And if you sit with that for a moment, it changes how you think about time. It's not just a ticking clock or a march forward from one day to the next. It's entropy, quietly spreading energy from one place to another, smoothing every difference it finds until none remain. The heat death of the universe is simply the point at which that process has nothing left to do. But there's one more way to look at it, a way that feels less like an ending and more like a kind of universal rest. Right now, the universe is full of movement and noise, stars roaring with fusion, galaxies colliding, matter falling into black holes. One day, all of that will quiet down, not abruptly but gradually, like a room falling silent after the last conversation fades. Everything will reach a point of deep, unchanging balance, and entropy will have finished its work. And while that might sound empty, it's also peaceful. No more burning, no more scattering. Just a vast, even stillness. If time has a destination, that's it. But for now, we are so far from that horizon that all it really does is remind us how much life still fills the middle. Because before the cold end comes, before the universe falls completely silent, there is still movement, still warmth, still endless pockets of order defying entropy for a while. You can find them in the stars above your head. You can find them in the small comforts of your room. You can even find them in yourself, because every heartbeat and every breath is another small rebellion against the drift towards stillness. And that's where the story takes a turn, because while entropy is always moving forward, life finds a way to move with it, borrowing order from the universe for a little while before giving it back. And that small act of defiance, repeated everywhere, is what makes the world feel alive. If you want to see entropy in motion, you don't need to look at galaxies or the far future of the universe. You only need to look around your room right now. Everything near you, every object, every bit of air, every flicker of warmth is following the same quiet rule that governs stars and black holes. The difference is that here, it's so ordinary you barely notice it. Take the air, for instance. It feels still, calm, maybe even motionless, but it isn't. Every molecule in this room is moving, colliding, bouncing, and spreading out. If all the air were ever to gather in one corner, leaving the rest of the room empty, it would feel like magic. But it doesn't happen, because there are far more ways for air to stay evenly spread than to cluster in one place. That balance isn't forced, it's the natural result of entropy at work. Now think about heat. Right now, your body is warmer than the air around it. Without you noticing, you're radiating tiny amounts of heat into the space nearby. The walls, the floor, the objects in the room, they're all trading microscopic bits of energy with one another. It's not dramatic. There's no sound, no light, no sign of it happening. But if it ever stopped, time itself would stop with it. Even the device you're using to listen is part of this quiet exchange. As it runs, it releases warmth, just enough to bleed into the air, where it drifts outward and becomes impossible to get back. That energy doesn't disappear, it just spreads out so far and so thin that it's no longer useful. Another tiny line added to entropy's endless record, and it's not just heat. The smells in a room, coffee brewing, a candle just blown out, fresh laundry, follow the same principle. Molecules spread, mixing with the air until there's no trace of where they began. You can't reverse it. You can't pull them all back into their original places. Entropy has already scattered them, the same way it scatters starlight across the sky. Even dust is part of this story. Left alone, it never gathers itself into neat piles. It spreads slowly and inevitably until every surface shares it. You tidy it away, but without that effort it always returns. That too is entropy, an ordinary reminder that the universe prefers the states that are easiest to reach, the ones with the most possibilities, and you sitting there are part of it. Every breath you take pulls in air, mixes it in your lungs, and sends it back out a little warmer, a little more even with the room. Your body is constantly exchanging energy with its surroundings, whether you notice it or not. You're part of the same flow that turns hot tea lukewarm, that spreads smells through the air, that cools a room after the sun has set. It's strange to think that this quiet process in your room is the very same one that drives the universe toward its distant heat death. But that's the truth. There's no dividing line between the two. The air molecules bumping around you and the galaxies drifting apart in deep space are all chapters of the same story. Entropy doesn't care about scale. It's everywhere, always moving forward, always evening things out. And yet, there's comfort in that. Because while entropy runs in the background, you're not powerless in the middle of it. You can rearrange your room, you can make tea, light a candle, fold blankets, or open a window. You borrow a little order for a while, knowing it will eventually give way again. That cycle is not failure. It's what keeps the world in motion. If you pause and look around, you can almost feel it. The soft hum of a process so steady and familiar that you never had to learn it. It was simply always there. And once you notice it in your room, it's hard not to wonder where else it's been hiding in plain sight, shaping the way you remember the past and why you can't return to it. Because entropy isn't only in the air and the walls around you, it's written into the very direction of your own life. You've seen things break before, a dropped glass shattering on the floor, a favourite mug chipped at the edge, even a once warm drink cooling down until it's no different from the air around it. And each time it happens, you know, without even thinking about it, that it won't undo itself. The glass won't leap back together, the chip won't vanish, the tea won't grow hot again. That certainty you feel isn't just experience, it's entropy. When things break or scatter or fade, the universe keeps a kind of record. Not in words, not in images, but in the arrangement of everything around you. Each change leaves a mark, and once it's made, it doesn't get erased. That's why you can remember what has happened but not what hasn't. Think about memory itself. Your mind doesn't store the future, it can't. But it holds the past because the past has already happened, and every moment of it has been carved into the state of the world. When you see a broken glass on the floor, you know it was whole a few seconds ago because the pieces tell the story. The fragments, the sound of the fall, even the space it once filled, those are all traces. They point backward, and they only point one way. This is why time feels the way it does. You never wake up and find the past rewritten, because entropy doesn't move in reverse. The record it keeps is permanent. Each event spreads out through the world in heat, in sound, in motion, until undoing it would mean reversing not just the thing itself, but everything it touched. Imagine, for a moment, if you could actually watch this happen. Picture dropping that glass in slow motion. The pieces scatter, the sound ripples out, and a tiny bit of heat escapes into the room. Those ripples keep moving long after you've cleaned up. The sound waves bounce and fade. The heat mixes into the air. Even the tiniest vibrations spread out and become part of the background. The world moves forward, carrying the record of what happened in ways too small to see, but too real to ignore. That's why the future feels blank. It isn't written yet. There are no pieces scattered, no heat spread, no traces for you to read. Entropy hasn't left its mark there, and until it does, all you can do is wait for time to catch up. This is what makes the memory of broken things so powerful. It's not about sadness or loss, it's about direction. Every broken glass, every cooled drink, every chipped mug is a tiny reminder that the universe moves one way and doesn't turn back. That's not something to fight. It's what gives your life its shape. Without that one-way current, there would be no sense of before or after, no reason for memory to exist at all. And it's not just in objects, it's in you. Your own body keeps the same kind of record. The marks of old injuries, the way your muscles remember how to ride a bike or tie a knot. These are just smaller versions of the same principle. Entropy moves forward, and in doing so, it writes your history into you. Once you see it this way, even the smallest everyday changes look different. A candle burned down to nothing, a meal half eaten, a wrinkle in the pages of a book you've read too many times. None of these things are mistakes. They're evidence of time passing, proof that entropy has been here, leaving its signature on the world in ways you can trace if you pay attention. And if this is how the past is recorded, then there's something else it tells us. The future is still untouched, because entropy hasn't yet reached it. And that simple fact, the difference between what's recorded and what isn't, is why time always feels like it's pulling you forward. But there's another layer to this, because while entropy explains why things break and why we remember, it also explains why the universe feels so inevitable, why it always seems to prefer certain outcomes over others, and that has everything to do with probability. When you think about it, entropy isn't just about things breaking or cooling down, it's about what's most likely to happen. The universe doesn't choose disorder over order, because it prefers it. It simply follows probability, and probability is a quiet but relentless force. Imagine tossing a handful of coins into the air. They clatter down, some heads, some tails. You might get all heads once if you're lucky, but most of the time you'll get a mix. Not because heads is forbidden, but because there are far more ways to get a mix than to get every coin the same. Entropy works the same way. Take a messy room. There's only one arrangement where everything's perfectly neat. Books aligned, clothes folded, every object exactly in place. But there are countless ways for that room to be disordered. All it takes is one misplaced book, one unfolded shirt, one half-empty cup on the desk. An order slips a little further away. That isn't failure, it's math. It's probability playing out in real time. And once you see it this way, the arrow of time starts to make sense. You can't unscramble an egg, not because the laws of physics forbid it, but because there's only one way for the egg to be whole again, and trillions upon trillions of ways for it to stay mixed. Every second that passes pushes the universe toward the states that are easiest to reach, the ones with the most possibilities. This gentle tyranny of probability is why time always feels like it runs in one direction. It isn't forced. There's no cosmic referee. It's just that the odds of going forward are so overwhelming that going backward might as well not exist. A drop of ink spreads in water because there are infinite ways for it to diffuse, and only one impossible way for it to gather itself again. You can even see this in heat. When a warm cup of tea cools, its energy disperses into the room. Could it all randomly flow back in and make the tea hot again? Yes, in theory. But the number of microscopic steps needed for that to happen in exactly the right order is so absurdly unlikely that the universe will run its entire course without ever seeing it. Probability simply refuses to give it a chance, and it's not just objects. Your own life is built on these same odds. The reason you remember the past is because it's already happened, its traces scattered and multiplied in ways you can't undo. The future, though, is still wide open. Its record hasn't been written yet, because entropy hasn't had time to tilt the odds in any direction. Once you realise this, entropy stops feeling abstract. It isn't a force working against you. It's just the math of the universe, unfolding everywhere at once. Every gust of wind, every cooling drink, every star burning in the sky, they all obey the same simple logic. Things spread out, because spreading out is what's most likely. And this quiet statistical push is what makes time feel steady. You don't wake up one morning to find every molecule in the air suddenly clustered in the corner of the room. You don't see shattered glass leap back together or spilled milk crawl back into its container. You live in a universe where the odds are so lopsided that forward is the only direction you'll ever see. But there's something else hiding in this. If probability pushes the universe toward entropy, then what does it mean that you, sitting here, listening, breathing, are able to create little pockets of order anyway? How do living things carve out structure in a world that's always drifting toward balance? That question is where entropy's story becomes more than just physics. Because for a brief, astonishing window of time, life finds a way to push back. For all the inevitability of entropy, there's something remarkable happening in the middle of it. In a universe where everything spreads out, where order gives way to balance, living things somehow pull pieces of that order back together, at least for a while. You can see it in the shape of a tree growing from the ground, in the rhythm of your own heartbeat, even in the simple act of breathing in and out. Life doesn't break the rules of entropy. It bends them just long enough to exist. Your body is a perfect example of this. Right now you're warm, structured and alive because you're constantly borrowing energy from the world around you. Every meal you eat, every breath you take is fuel. Plants capture sunlight and trap it in their cells. You eat the plants, or the animals that ate the plants, and the energy flows into you. You use it to hold yourself together, to repair what's broken, to move, to think. But every bit of that comes with a cost. You take concentrated energy in, and you release some of it back to the world as heat, as entropy. This is what life is. A temporary local reversal of the trend, built on top of the trend itself. You keep yourself organized by constantly feeding the universe's tendency to spread out. The moment you stop, if you stop eating or breathing or moving, that borrowed order slips away and entropy takes over completely. And it's not just you. Every living thing does the same. A tree grows upward against gravity because it's powered by sunlight. A bird flies because it burns food for fuel. Even the smallest cell takes in energy, uses it to build, and then leaks it back out as heat. Life is not a defiance of entropy. It's a clever partnership with it. You create little pockets of structure by paying the price of disorder elsewhere. This is why life feels so different from the rest of the universe. A rock just sits there. It doesn't take in energy. It doesn't repair itself. It doesn't fight the drift toward balance. But living things are in constant motion, constantly spending energy to keep their own order intact. It's a beautiful, fragile trade. The universe gives you the chance to hold yourself together for a while, and you give it entropy in return. When you think about it this way, it's almost comforting. You don't have to fight against the universe. You're part of its flow, and for a small span of time you get to build patterns inside it. Heartbeat after heartbeat, breath after breath. Eventually, entropy will win. It always does. But in the meantime, you live in this extraordinary in-between space where energy is still moving and the arrow of time is still pointing forward. And that's what makes life so tied to time itself. You can feel it in your own body. You age because entropy is working, one cell at a time. You grow because energy is borrowed and used. You rest because every living thing needs to pause and gather enough order to keep going. Every part of you, from the smallest chemical reaction to the steady pulse of your heart, is linked to the same rule that governs the stars. And that's not bleak. In fact, it's what makes you part of something bigger. Entropy isn't only the reason things fall apart. It's the reason anything happens at all. Without it, there would be no flow of energy for life to borrow, no sun to warm the earth, no food to eat, no air to breathe. The same process that will one day cool the universe to silence is the same process that lets you be here right now, alive in this brief and luminous moment. And it raises a strange, beautiful question. If life can exist in a universe ruled by entropy, if it can carve out these little islands of order, could there be other ways for time to move? Could the arrow ever point in the other direction? If entropy is what pushes time forward, it's natural to wonder what it would mean for time to run backward. You've probably imagined it before, even if only in passing. A broken glass lifting itself from the floor, shards spinning together until they're whole again, smoke drifting back down into a candle, the sun rolling up from the horizon instead of down. It's a strange thought, but it raises a fascinating question. Is it truly impossible, or just unimaginably unlikely? On paper, the laws of physics don't forbid time from reversing. If you zoom into the tinier scales to single particles colliding, the math works just as well forward as it does backward. A single collision looks the same in reverse. But entropy doesn't live in those tiny isolated events. It emerges when you look at everything at once, every particle, every interaction, every bit of energy spreading in every direction. And in that view, backward is buried under a mountain of probability. Think about that scrambled egg again. If time could flow backward, every molecule in that egg would have to retrace its steps perfectly, each one finding exactly the right place to return to. The odds of that happening are so staggeringly small that you could wait longer than the universe has existed and never see it. Entropy doesn't forbid backward motion. It simply drowns it in impossibility. And yet, there's a reason this idea captures us. Part of it comes from the way our minds work. You remember the past, but the future is blank. It's tempting to imagine what it would be like to turn around and walk back through that blank space, to reclaim what has already been lost to the arrow of time. Maybe it's why so many stories play with the idea of time reversal, Not because it's realistic, but because it's the one thing that feels forever out of reach. Even in physics, there are strange corners where time seems to blur. On the smallest quantum scales, particles can behave in ways that don't fit our everyday sense of direction. Some processes even look reversible, at least in theory. But as soon as you step back and include the rest of the universe, the heat, the spreading energy, the countless invisible interactions, time snaps back into place, always moving the same way. Entropy wins by sheer numbers, and in a way that's a good thing. If time could run backward, the world wouldn't feel stable. You wouldn't trust that the broken glass will stay broken, that a sunset will lead to night, or that tomorrow will follow today. The forward pull of entropy is what makes the universe predictable. It's why you can make plans, why memory has meaning, why your life feels grounded in cause and effect. Backward might be an intriguing dream, but forward is what gives reality its shape. Still, it's fascinating to imagine. If time could reverse, it wouldn't just change the world, it would erase it. Every trace of every event, every record in Entropy's invisible library would have to be undone. Memory itself would vanish, because it's built on the past, and the past would no longer exist. The very thing that gives you your sense of self, your history, your story, would dissolve into nothing. That's why, even if it were possible, backward time would be unrecognizable. It wouldn't feel like living life in reverse. It would feel like not existing at all. And so, we move forward, carried along by the same one-way current that cools your tea, dims the stars, and gives every moment its place in line. But instead of wishing it could go backward, there's another way to look at it. The arrow of time isn't just a limitation, it's also what makes every moment unique. Nothing repeats exactly, nothing rewinds. Every second is new, written into Entropy's record the instant it happens. And maybe that's the point. The universe doesn't need to run backward. It only needs to keep unfolding. And in that unfolding, in that steady drift forward, we find the rhythm that carries us through our days. Because if entropy is the reason we can't go back, it's also the reason forward exists at all. And that forward motion, strange as it is what makes time feel real. If you've ever sat quietly and noticed the way time seems to stretch or shrink, you already know that it isn't just a matter of clocks. There are hours that vanish in an instant and minutes that feel impossibly long. Time doesn't just move forward, it feels a certain way. And that feeling, strange as it seems, is tied to the same thing that drives the universe. Entropy. When you remember something, you're looking backward at events that have already been written into the record of the world. Your morning coffee, the sound of a conversation, the warmth of sunlight through a window, these moments exist in memory because they've already left their mark. Heat has been exchanged, molecules have shifted, tiny changes have rippled outward until they're impossible to undo. That trail is why the past feels solid. The future, though, feels empty, not because it isn't coming, but because it hasn't been written yet. Entropy hasn't had the chance to leave its traces there. No spilled heat, no scattered marks of events, nothing for your mind to hold on to. You can imagine what might happen, but it's always just a guess, because probability hasn't played its hand yet. This is why time feels like a narrow bridge between the weight of the past and the blankness of what's next. Even the way you sense time changing, why some days blur by while others drag, comes from the way your brain measures it. You don't really feel seconds ticking, you feel change. When nothing much happens, there are fewer changes for your mind to record and time feels slower. But when events stack up quickly, when everything is in motion, entropy is leaving mark after mark, and your brain counts every one. The more marks, the faster time seems to run. This is why a quiet evening in a familiar place can feel slow and soft, while a busy day in a new city feels like it's gone before you can catch your breath. Both are built on the same clock, but what you feel is the pace of change, the steady trail of new records entropy writes down for you. And there's something strangely grounding in that. Time doesn't just happen to you. You live inside it. Every breath you take, every step you walk, every small shift in your surroundings is another piece of evidence that entropy is still moving forward. The warmth from your skin leaking into the air, the faint hum of an appliance using power, the distant glow of sunlight still spilling through space, all of it adds up to the same direction, the same flow. When you think of it this way, time stops feeling like a mystery and starts feeling like a companion. You're carried by it, the way a leaf drifts along a river. You don't have to force it. You don't have to hold on. You only have to move with it, because it will always move on its own. And this is why time has a feeling at all. If entropy didn't exist, if nothing changed, if every atom stayed frozen in place, there would be no before or after. Just an endless, unbroken stillness. No past to remember, no future to imagine, no present to live in. Entropy gives you all three. It writes the past, clears the future, and pulls the present forward with it. But if time feels this way because of entropy, then it also means that your own body, the way you burn energy, the way you exist in this constant exchange, plays a part in how you move through it. You are quite literally made of the same processes that keep the universe ticking, and that means the feeling of time isn't just out there in the cosmos. It's in you, right now, in every breath, every heartbeat, every quiet second that passes without you needing to do anything at all. You don't need to look at stars or galaxies to see entropy. You're carrying it in every cell of your body. Right now, as you sit and breathe, you're a small, intricate engine of thermodynamics, constantly trading energy with the world around you. Every breath, every heartbeat, every tiny movement is part of the same one-way current that pushes the universe forward. Take your breath, for example. When you inhale, you pull in oxygen from the air, a small, invisible store of order. Your body uses it to burn the food you've eaten, breaking down sugars and fats into the energy that keeps you alive. But that process doesn't end where it starts. The energy doesn't stay neat and contained. Some of it powers your muscles, your thoughts, and the repairs happening silently in your cells. The rest spills outward as heat radiating from your skin, warming the air around you in tiny constant waves. Even when you're still, your body is busy. You're like a quiet fire, burning steadily but never consuming yourself all at once. You eat, you breathe, and in return you give heat back to the world. Entropy is the price you pay for staying alive, but it's also the reason you can live at all. Without that flow of energy, nothing would happen. Your cells would freeze in place, your thoughts would stop. You'd be a machine without power. Every heartbeat is part of the same exchange. Your blood carries oxygen and nutrients to every corner of you, fueling countless microscopic reactions. Each one releases a little heat, and that heat drifts outward, joining the slow, steady balancing act happening everywhere else. You never feel those individual exchanges, but you're surrounded by their quiet evidence. The warmth of your skin, the way you grow tired if you don't refuel, the way you cool down when you rest. Even the simple act of exhaling is a piece of the puzzle. When you breathe out, you release carbon dioxide, carrying away some of the energy you've already spent. That breath mingles with the air in the room, mixing and spreading until it's indistinguishable from everything else. Another tiny contribution to the universe's record of changes. And here's the strange, humbling thing. The same rules that govern your body are the ones that govern the stars. You run on borrowed energy just as they do. The difference is only scale. They burn hydrogen, you burn calories. They radiate heat into space, you radiate heat into the room. Both of you are part of the same flow, order unraveling, energy spreading, entropy moving forward. But there's a kind of beauty in that. You're not separate from the universe's thermodynamics, you are an example of it. Your body is proof that entropy isn't just about things falling apart, it's about things happening. Without it, you wouldn't age, but you also wouldn't live. Time would have no direction, and nothing in you could move. And yet, in the middle of this one-way drift, you've built a temporary pocket of order, yourself. You eat, you rest, you repair, you keep going, all while entropy ticks along in the background. You're borrowing a little structure for a while, knowing it won't last forever, but also knowing it doesn't have to. Because that's the quiet truth about living in a universe ruled by entropy. You don't escape it. You move with it. Every breath, every heartbeat, every small exchange of heat between you and the world is a reminder that you are part of the same steady current as everything else. And once you see yourself this way, you stop feeling separate from the universe. You start feeling like what you've been all along, a temporary, beautiful arrangement of energy and matter, riding the arrow of time just like the stars, the oceans, and every grain of dust in space. And if you can accept that, then you can begin to see something else hiding in this constant flow, something comforting in a way you might not expect. Because entropy isn't just about endings, it also carries with it a quiet kind of peace. When you hear about entropy, it's easy to think of it as a force that only takes. Things cool down, break apart, scatter and fade. But if you sit with it long enough, if you watch the way it moves through the world, you start to notice something else. There's a strange kind of comfort hidden in it, a calm acceptance built into the way the universe works. Look at the small things around you. A candle burns down, its wax melting and its heat drifting into the air. Nothing about it feels tragic. It's simply what the candle was always meant to do. A cup of tea grows cold. A breeze dies down. The day fades into night. None of it is loss. It's just the natural settling of things, the quiet movement from contrast to balance. Entropy doesn't rush. It doesn't tear things apart in anger. It lets them go, one step at a time, and you can see the same thing in yourself. You breathe out and release a little heat into the air. You get tired and rest. You eat, you burn energy, you rebuild, and then you do it again. You don't fight entropy. You live alongside it. You're made of it. Every moment of your life is another small exchange in this long, patient process. There's something deeply reassuring about that. You don't have to hold the universe together. You don't have to force time to keep moving. It already does. The warmth will always flow outward. The air will always mix. The stars will always burn and dim in their turn. You're carried along by the same current that moves everything else. And for a while, that current holds you here, alive, breathing, in the middle of it all. And when you stop trying to fight it, it stops feeling harsh. A warm drink cooling isn't a failure. A sunset fading isn't an ending. These are just the natural ways the universe relaxes into itself. Even the far-off heat death of the cosmos, as strange as it sounds, is less a catastrophe than the ultimate stillness, the final balancing out of every difference. When you see it that way, entropy doesn't just explain why time moves forward, it gives you permission to move forward with it. You can let things change. You can let moments pass. You don't have to hold on to every single one of them, because the flow that carries them away is the same one that brought them to you in the first place. Maybe that's why there's a kind of peace in watching small, ordinary things, steam rising from a cup, a candle flickering low, even your own breath moving in and out. These are reminders that you're part of something steady, something vast and unbreakable. The world has been shifting this way since the beginning, and it will keep shifting long after you're gone, and there's comfort in knowing you don't have to control it. You only have to live in it. And once you feel that, entropy stops sounding like a threat. It becomes what it has always been. The quiet rhythm of the universe, the reason stars shine, the reason you exist, the reason time feels the way it does. Not a force to resist, but a kind of deep, universal exhale. And if there's a stillness waiting at the end of all things, then for now there's also this moment, you here, breathing in the middle of it all, surrounded by warmth, movement and change. And as strange as it may seem, that single fact is enough. If you follow the story of entropy to its farthest edge, there comes a moment, so distant it's almost beyond imagining, when everything that can happen has already happened. The stars that once lit the sky will have burned out. Galaxies will have grown dim and quiet. Every last difference in temperature, every pocket of concentrated energy will have been spent. This is the last tick of the universal clock. Not a dramatic one, not an explosion or a sudden collapse, just the final, unhurried step in the slow drift toward balance. By then, no new stars will form, no fires will burn, every trace of heat will be spread so evenly that there will be nothing left to power change. It will be the ultimate stillness, no more flowing rivers of energy, no more bright contrasts between hot and cold, just a perfectly even calm. Time itself, in any practical sense, will have nothing left to measure. And yet, this ending isn't frightening. It isn't even really an ending. It's more like the long exhale of a universe that has been moving for untold ages and is finally at last at rest. No tension, no imbalance, no unfinished business, just quiet. If you picture it, you might imagine a vast dark space with no stars left, only the faint afterglow of everything that came before, stretched thin and silent. It isn't lonely, it isn't sad, it's simply the natural conclusion of the same process you see in small ways every day. A candle going out, a cup of tea cooling, a deep breath let go. Right now, though, that future is so far away it might as well not exist. You live in a universe still buzzing with warmth and motion. Stars are burning, planets are turning. Life is borrowing tiny pieces of order and passing them forward, second by second. Entropy may write the last chapter someday, but tonight, you're still somewhere in the middle, surrounded by everything that makes the story worth telling. And maybe that's why there's something soothing in imagining that distant quiet. Because it reminds you that all the noise and motion around you right now is temporary. Every bright thing will eventually fade, but in that fading, there's no violence, only a soft and steady drift toward peace. The universe is in no hurry. It has been unwinding for billions of years. It will keep unwinding long after the last star has gone out. And you, here, in this small moment, are part of that same flow. One breath, one heartbeat, one tiny flicker of borrowed order in the long, unbroken movement of time. And as you sit here, maybe you can feel it, that quiet current beneath everything, the one that's been carrying the universe forward since the beginning. It's not something you have to follow, you're already moving with it. And that's the beauty of the last tick of the universal clock. It's not really the last of anything, it's just where the story settles, slowly, gently, until there's nothing left to change. But before that distant quiet arrives, there's still this moment. There's still the flow you're in right now, and in that flow there's a strange and calming truth. You don't need to reach the end to find rest. You can find it here, in the movement itself. The universe may be moving towards stillness, but you don't have to wait for that distant quiet to feel it. You're already surrounded by it, tucked inside the same flow that carries stars and galaxies toward their slow settling. Right now, in this moment, entropy is working gently around you, smoothing edges, cool in warmth, softening everything into balance. And in that movement, there is rest. Take a breath. Feel it go in and out. That simple act is part of the same current that has been running since the first second of time. The warmth from your body drifts into the air folds back into the room, and everything finds its place. It's not rushed. It doesn't need to be. Entropy isn't a race. It's the quiet rhythm that underlies every change, from the smallest shift in your room to the slow unwinding of the cosmos itself. And maybe that's what makes it so strangely comforting. You're not separate from it. You're not standing still while time moves around you. You're inside it, carried along by the same invisible tide that cools a cup of tea, dims the stars, and one day far in the future will bring the universe to its final balance. There's no need to hold on. You don't have to fight to keep every moment from slipping past. They're supposed to. That's what gives them meaning. Each second you live becomes part of Entropy's record, written into the fabric of the world in ways you can't erase. That's not loss. That's time doing exactly what it's meant to do. And here's the quiet truth. You don't need to reach the end of the story to rest in it. You can find that rest right here, in the middle, because this moment is already part of the same flow. You, breathing in your room, the hum of the air, the faint warmth of the world around you, all of it is exactly where it's supposed to be. So let the universe keep moving. Let the stars burn, let the days pass, let the current of entropy do its work. You don't have to run ahead of it or turn it back. You only have to be carried, the way everything else is, and as you sit here listening, you can feel it if you pay attention. The quiet engine of time, steady and unhurried, guiding everything forward. You don't need to hold it, and you don't need to stop it. You only need to rest in it, because in the end, that's what entropy gives you. Not just the future, not just the past, but the calm certainty of this moment, exactly as it is, flowing the only way it can, forward. And that's where we'll stop for tonight. Not because the story of entropy has an ending, but because it doesn't need one. It keeps going, quietly, all around you, in every cooling breath of air, in every distant star, in every second that slips by unnoticed. If you've been listening this whole time, maybe you feel it now, not as something to solve, but as something steady, something that's always been there. You don't need to fight it. You don't even need to think about it. You can simply rest in it. So wherever you are, let the world soften a little. Let time keep moving without you needing to chase it. Close your eyes if you'd like. Let the steady current of entropy carry you the same way it carries everything else. And if you found this soothing, if this quiet space gave you a little peace, you're welcome to join me again next time. There are always more stories to tell. About the universe, about time, about the calm hidden underneath all of it. For now though, just breathe. Let yourself settle. The universe will keep ticking along exactly as it always has, and you, here, in this small quiet moment, are part of it. Good night.